We're going on now to the second module in which we will be doing primarily what we did in Math 105 before, and section 1 of chapter 5 deals with an introduction to polynomials, polynomial functions. And here are some of the objectives we will be covering. Now, for all of this, keep in mind that I have read the textbook. I have made a video using the textbook and introducing it item by item. So your basic role as a student is to read the textbook. Here what we're doing is outlining the major topics and helping you to focus on what is needed to get mastery so that when you take the test, you do well. Okay. So, example 1, identify the terms of the polynomial. Well, this is really critical. What is a term? Well, we say a term is something in an expression that is separated by either a negative sign or a positive sign as a general rule. So there's a negative, there's a positive, there's a negative, there's a negative. So first, let me ask, how many terms are here? 5. What are they? Well, I'll just underline them for you. There's 1, 2, 3, 4, and 5. Now, when we look at a term, like let's pick the second one, a negative 11m to the 5th. Notice that's just one term. And in it, we have a numerical constant here that is referred to, you may recall, the numerical coefficient of this. Then we have a variable, and that variable has an exponent on it. Now remember, the variable part is called the base, and the number of times that base is multiplied by itself, up here this is the exponent. Now, in this section, we're going to give another little definition to the exponent up here. We're going to call that the degree, as we'll see here, of this particular term. Now, the degree is arrived at by adding all of the exponents within a term. So within this term, there's only the 5. So the degree of this term is 5. And now let's take a look at what we have down here for number 2. What is the degree of this term? And the answer is 2. The degree of this term, 10. The degree of this term. Now notice there isn't an exponent that is showing on the x. When you have that, we have the exponent of 1. We just don't write the 1. So the degree of this is 1. Now here we don't have a variable. Now theoretically you might think of it as being x to the 0 power. And what did we say that any term to the 0 power is? 1. So when there is no variable, the degree is to the 0 power. Now, again, in our term, we said the numerical part was the numerical coefficient. So that's what they're asking us to identify here. So take a moment. What is the numerical coefficient of this term? 9. And this term, and you have to include the sign, -7. Now once again, if there is no number in front of a variable, there's a 1 there. So the numerical coefficient of this is a 1. And how about this one? Well, there's no variable, but the numerical coefficient is there. It's just our constant. Okay? So again, if you're reading your textbook, they're going to give you lots more information about all of this. This is just meant to be a focusing on the specifics of these examples. You'll be getting more examples as you do your study plan. All right, let's raise it up. Before we go down though, let me just go over a couple of other things that I don't see them mentioning it here. Now, when we have an expression with 1, 2, 3, 4, 5 terms, we call that a polynomial. If it's only one term, we call these monomials. Now over here, when we have 3 terms, we're going to give this an additional name. Beside being a polynomial, it's also a trinomial. And if there are only 2 terms there, that would be a binomial. And we said one term was a monomial. You may have heard those words before. I just want to review them. Okay, now for example 3. And here what they want us to do basically is to think of this as sort of a t-chart where we're going to put an x value into this function. So this would be f of x. Remember, we thought of this also as a y. And our values here are going to be a -4. That's the value we're going to substitute for the x. This is how they show it. And then we're going to use a 0. So if x is a -4, and I would just do the substitution. You want to get it right. 3 times -4 cubed plus -4 squared minus 20. So now that you've accurately substituted, you can work it. Now a -4 to the 3rd power, an odd number, this is going to end up being negative. And that's a -64. And times a -3. So here we have a negative times a negative. That's going to give us a positive. So -3 times -64, put that in my calculator. I got a positive for the sign, 192. A -4 times a -4 is a positive 16, and this is just a -20. So I added these two together, and I believe I got a 108. Then I subtracted 20, I got a 188. And I put this in my calculator. So up here, when x is a -4, this comes out as a 188. Now, when they ask for a 0, that one's sort of easy to do because then anything times 0, this is going to be a 0. 0 squared is 0, so this is just -20. But again, you're looking for a method to do things like this. They're asking you a function of this when x has these values. A good way to organize your data, you want to end up with the right answer. Okay, part B. The area of a circle of radius r is given by this polynomial function. And this is pi r squared is the area of a circle. Where pi is an irrational number, we're going to use 3.14. What is the area of a circle with a radius of this? Well, it's just substitution. Area equals 3.14 times 1.15.5. Now here's where it's critical. What do we do with the radius here? We have to square it. So I'm going to put that in my calculator. And I get, after I square this, remember you have to do that first. Then you times it by this, and you get this. Now often they're going to ask you to round it to the nearest tenth, hundredth mile. Notice if we multiply it to the hundredth of miles, we're going to add a 1 here. This becomes a 9. A tenth of a mile, this 8 or 9 becomes a 4 here. So depending what they're asking, this is the exact answer of what we have here. Okay, let's go on. Now, here they're asking us to estimate the range of the function from the graph. Well, remember, there is an arrow there, and there is an arrow there. And in a sense, this is going this way eventually, and this is going this way eventually for the domain, but here they're asking for the range, and it's also going up this way and going down that way. So estimate the range of the function. It will be from this direction down here, negative infinity, and it goes up to positive infinity. And by the way, that would be the same for the domain as well. It says use a graphing calculator to graph this in standard viewing window and estimate the range of the function. Okay, we are, again, I'm not sure how much we're featuring the use of a calculator in our course, but what I'll do is I'll put that in my calculator, show you what it looks like, and then we can, well, a couple of things. As we look at this equation down here, this is y equals this. We see that we have a sort of a y-intercept here of a positive 2, which is right there. And this goes up to, according to what I got on the graph, up to a 6 here. This is a 6. This is a 2. And it's sort of a parabola-ish type of thing because of its being negative out in the beginning there. It opens up to the bottom. Now your regular parabola, opens up this way, but anything with a negative value out in front here will open up this way. But because this is to the 4th power, you get this funny shaped curve. And again, we're not expecting you to do that. But if you knew this was the graph, what would be the range of that? Well, it's coming from negative infinity going up to what? 6. And it looks like 6 is in the set, so I'm assuming it's something like that. Again, the answers are down below. Now, as I look at this, they are also asking for the domain. This was the domain that we said, and then this was the range. And that worked out very well well, actually it was no, I guess this was the range as well. Here they're only asking for the range. So again, in A, the range, in B, the range. All right, let's look at our last few as we do what is asked here. Now, if you find that I repeat certain things, good. That's what I want to do. Through repetition, hopefully you can get some long-term memory, which is what you want. So what is our technique here of combining like terms? Well, a like term has exactly the same variable. So you could do this one by mentally, but I'm suggesting you do it by lining up your like terms vertically. There's an 8x and there's a 1x underneath. This is one like term. And then we have an 18 and we have a -5. So as we add these up, this is 9x, and here we're just subtracting, plus 13. So that's pretty straightforward. Now as we do this one, gets to be a little tricky, and you're going to get lots that are challenging. This is just to show you how it's done. Well, let's line them up like terms. -5n squared. Now we're looking for some other n squares. There's one right here. Plus 3n squared. And then we have an n here. So we have a plus 2n and a plus 1/4 n. Well, we have fractions. We're going to have to work with those. Then we have a -9 and a -4. So again, much of this is easy, but this part will be challenging, and I'll show you that in a moment. So here, what will our sign be? A -2n squared. Now, I was working with a student a few weeks ago, and when they did this, they were also multiplying. No, we're just adding. When we add, the variable and its exponents never change. Never change. Never change. So we want to add these up. So we have to have fractions here. Well, let's convert 2 to a fraction with a denominator of 4. So we have 2/1. We want to change it to a denominator of 4. Well, what do I multiply the 1 by to make it 4? Well, a 4. So I can multiply any fraction by 1 in the form of this case 4/4. So this becomes 8/4. And if we simplify 8/4, we get a 2. So this is actually 8/4. Now we can add these. Just adding our numerator. 1 and 8 is 9/4n minus 13. Now keep in mind you want to do it so you get the right answer. You may be taking shortcuts when you're doing your practice. That's not too bad a thing. When you're taking your Quizmes, you want a little more accuracy because that will generate mastery points. But when you take your test, you want to really be sure and, be careful, check your work, especially if you have time within the time frame of the test. Now, for number 6, again, the strategy of lining up your like terms vertically. So let's just do that. The first one is -5x cubed plus, now I don't have a x to the second here, So I'm just going to put a space holder there. Does this have any value? No, it's 0. But it gives me a place to put my like term underneath. So now here's another critical part. You must do this when you have a negative sign. This is subtraction. What do you do to all of these things inside the parenthesis that follows a negative? Well, the answer is you change all of these signs. So where this was a positive, it's now going to become a negative 9x to the third. Where this was a negative, it now becomes a positive. And I'm putting there the 1 for emphasis. This was a positive, now becomes a negative. This was a negative, it now becomes a positive. So the rule is, when there is a negative in front of a parenthesis, you remove the parenthesis and change all of the signs. So many times people will just change the first one. Then of course they get it wrong. The rule is, when you have a negative in front of a parenthesis, you remove the parenthesis and change all of the signs. And I'm strongly suggesting you line up your like terms vertically. Again, you want to get accuracy. Negative 14x to the third plus x squared. Again, we don't usually write the 1, but you know it's there. Now here, again, we don't write the 1, but the answer is going to be negative x. And then here it's going to be plus 3. And that's what they have right there. How did we get it? Again, we just copied these down. We left a spot where we would line up the like terms of that degree. And there's one other little thing too that they're not showing you, and I'm going to show you that here before we go. If we have 2x to the third, y to the fourth, z to the second, plus 2x, y, z, are these like terms? This is a review. No, because they don't have the same exponents. So they're not like terms. What is the degree of this term? Well, we had said earlier it was the sum of the exponents on the variables. So this is going to be 7. This degree is 9. And here, these are just all 1s. So the degree of this term is 3. Now the question is, if this were a polynomial, a binomial expression, what is the degree of this expression? And the answer is, it's the degree of the highest individual term in your expression. So the degree of this expression is 9, the highest degree of any individual term. And I think that will cover it. Do your practice, quiz me, get your mastery as we work in Module 2.